Hi guys, it's Talha here. I hope all of you guys are doing great. So today, what we learned at the university was about we learned and we solved some problems related to the rules of limits of functions. So today what we are going to discuss will be about rules of limits of functions. I've discussed them earlier in a video, but here I'm going to discuss it again so you guys can make sure that you guys are clear on this topic. Then we are going to discuss the most important rule or the theorem. Instead this is a theorem, that is sandwich theorem. So we're going to discuss what is sandwich theorem. Then we are going to discuss, I'm going just going to touch this topic from the top, that is the hospital rule. I'm going to discuss what is this hospital rule. We are going to discuss we are going to discuss how to solve limits when it's not solvable, means like it gives you an undefined answer. So I'm going to solve an example, and then after that what we are going to discuss, if we have time, we are going to discuss some topics we learned today in programming. So what we learned was user-defined functions, and we learned how to use functions, what are actual parameters, what are formal parameters, and how to how to write function, and then how to call them. So if we have time, we'll discuss what are functions and how to use functions, how to call functions in C++, and how to follow the syntax rules and all that related to the functions in C++. So let's start with rules of limits of function. So basically, let's start from the first rule. So we have the sum, we have the sum rule, where for example, if of limit of x approaches c, of f of x plus g of x. So you can write it as limit of x approaches c to f of x plus limit of x approaches c. So it's the limit applies to both of them, so you can write them separately. Secondly, we have the subtraction rule, where you just change the sign. It's going to be the same. Third, we have multiplication rule. So here this will come like this, and we have f of x into, or f of x dot g of x. That means they both are multiplying. So there we will have limit x approaches c to f of x into limit of x approaches c to g of x. In the same way, we have the division rule, where we have the same limit. We have f of x divided by g of x. So what we do is we apply limit to both of them separately, given that the limit of g of x. So here, limit of x approaches c of f of x divided by limit of x approaches c g of x. Given that limit of x approaches c of the function g of x is not equal to 0, because if it's 0, it will give you an output that will be undefined. So this, given that it's not equal to 0, so it's going to follow this rule. Then we have constant multiple rules. So for example, we have limit of here we have limit of x approaches c to, for example, 2 of f of x, or a constant, or k, or for example, I just wrote here I wrote 2 here. So you have f of x. This implies it will be 2 will come outside, and you have limit of x approaches c to the on to of only the function. You know, the constant jumps outside, or the constant just comes outside. Then we have the rule which is called the power rule. So for example, you have limit x approaches c, you have f of x, you have f of x, you have f of x to the power, and you know this is included in a power. For example, square, for example, this is all f of x square. So what you're going to do is it will be limit of x approaches c, limit of x approaches c, f of x, this will be whole power. So the limit will go inside, and this is going to take the power of the whole limit plus the limit of the function. So these are all the rules which are related to the functions, which are related to the limits of the function. Now let's discuss this sandwich theorem. What is the sandwich theorem? So for example, you have three functions. You have g of x, you have f of x, and you have h of x. So what sandwich theorem says that if g of x, if f of x is greater than or equal to g of x, and if f of x is smaller than or lesser than or equal to h of x. So what it says is, if this is true, then the limit then for example, if h of x, then the limit if g of x and h of x are approaching to the same limit. So for example, if g of x is approaching to limit, and that limit is L, and h of x is also approaching to the same limit, that is L. So that means that means the limit of f of x approaches to L will also be L. You know, it will approach the same limit these two functions are approaching. So when they approach the same limit, the g of x and h of x approach the same limit, f of x will also approach to the same. F of x will also have the same limit, the same output as them. So this was what sandwich theorem says. Now we have L'Hospital rule. So what it says, for example, if you have a limit, and it gives you a dividend at 0. For example, you want to find f of x, and it gives you a dividend 0. If and only if the numerator is also 0, if the numerator is also 0, then its limit exists. Its limit exists. But if the numerator is not equal to 0 and the divisor is 0, its limit does not exist. So this is what L'Hospital rule says. I'm just studying it from the top and not going that deep, but you guys just get the gist that when the numerator is 0, the limit exists, and when it's not equal to 0, it does not exist. Now for example, you have a question. For example, you have a question where you have, for example, limit of x approaches 1. Limit of x approaches 1. You have x squared divided by x minus 1. So here, if you were to solve this problem, if you put 1 instead of x, you know, that is how you solve the limits by substitution. If you put 1 instead of x, it will actually give you 0. It will actually give you 0. So what you do instead is you try to factorize this polynomial or rational function. You try to factorize this to find the same factors, and then cancel them out. You cancel them out, and then when you can see that if you substitute the limit and it is not giving you an undefined answer, and then you if you think that you can find the limit of this function where it's not giving you an undefined answer, then only then you can find the limit, because right now if you put 1, it will actually give you 0 and it will be undefined. So you have to factorize this problem before substituting the limit into this function. Now let's discuss the what we learned today in a programming class. So what we learned was about user-defined functions, user-defined functions, and we learned how to call a function and how to first let me tell you what is a heading of a function. So for example, if you want to make a user defined function, so yesterday we learned about predefined functions that are predefined, their code is pre-written, but today we are learning about user defined functions. So user defined functions are the functions which you make customarily, you customly make the functions to help you achieve some task in your program. So what you do is how the syntax of a user-defined function heading. The heading of the function is like this. You first mention the data type, the or you can say in mathematical terms the range or the answer this function is going to output. What data type is that answer going to be of? Then you're going to suggest a function name, and also take care when you take a lot of care when you suggest a function name, because that function name should be meaningful, because if it's not, you're not going to know that what is this function about. So be careful when you choose a function name. Then after function name, this is the heading of a function. Then we have parameters, and before parameters you declare what type of parameters you're going to declare. So here we are going to declare a formal parameter. So parameter, parameter, or parameters. So if it's two, you're going to declare another one, and it's going to be parameter. So there are actually two types of parameters. One is formal parameters, one is a formal parameter, and another one is actual parameter. So what is the difference between these two parameters? So what actually formal parameter is? Formal parameters is actually the variables or the general variables you declare in the space where you have parameters. Where when you are making a function, when you have the function in the function inside the function heading, you declare these formal parameters, which in return when you call the function, the actual parameters take the place of formal parameters. In actual parameters you declare, or you put the actual values you want to be solved through that function. So you put expression or the variables which you have declared prior to calling this function. So for example, you have a variable a, b, and you have already given them some values, and then you declare these, or you put these variables into this actual parameter when you call the function. I'm going to come to that calling the function in a little bit. So here you have this was the function heading. So after that there is a function body. So you put an opening brace, and then you put a closing brace, and here you write all the necessary code, all the necessary code you want this function to perform. So all the code you want this function, because you make functions to do specific tasks. So here this code is going to do your task. So it's up to you whether what a name you give, and what data type, what kind of parameters you choose, and then what code you write in here will be executed when you call a function. Now let me discuss how do you call a function. So for example, okay, I'm just explaining it generally. So I'm not going to write the function and the code all. I'm just explaining it generally. So in general, if you want to call a function, what you're going to do is you are going to write the function name. You're going to write the function name inside the expression. And you know how do you write expression? You write it in an output statement, either you assign it to a variable, but to store its value. But here I'm just going to, for example, you have a cout statement, and here you're declaring, or you're calling this function inside the expression area. So here you write the function name, and inside the parentheses where you declared the parameters, the formal parameters prior to calling this function. So here you write the actual parameters, which, the actual parameter means the parameters or the values or the arguments you want that function you're calling to take and then provide you with an output. So this can be a variable, or this can be an expression. So for example, you provide it with an integer value or a double value based on the data type you have given in the function heading. So for example, you write here a 5 or 6, or you can write a or b. Let's say this is a function, and function name is larger, and the data type is double. So here you're going to declare, here you're going to write double parameter, for example x, and here you're going to write double, because it's going to take two parameters, going to compare two values to see which one is larger and which one is smaller, or which one is larger. So here you have double, and you're going to declare y. So after so what this function is going to do, when this function is going to see this expression, when you call the function, the control will actually transfer the control of this function, which will actually transfer from this place where you call the function to the function body itself. It's going to take these formal, first it's going to take these actual parameters. It's going to substitute these actual parameters into the formal parameters you have declared, or you have given in the function heading prior to calling this function. And after that, what it's going to do, it's going to solve this function to achieve a task you want it to achieve, and then it's going to return. In the function body there will be a statement called return. So what it's going to do is going to return the answer, or the value, or an expression, for example a, for example max or something. Is going to return that to the function name, and what after that, when you call this function, it's going to transfer the control over to the function body. Is going to solve it, is going to produce a value. That value is going to be returned to the function itself, and that is what is going to be displayed as an output. So this was how you call a function, and this is how a function executes. The control transfer to the body, it executes, it gets processed, it returns a value to the function name itself, and then that is how it's going to provide you with an output. Also, if you first have to write the function itself, or user defined. You first have to write the user defined function, and then you are going to call it. So there are actually two ways. For example, you have a function, and here your program ended right here. So there are two ways. Either you've got to write your function. This is actually all of this. When you write it a second time, it's actually called the prototype. So after this, either you have two ways. So either you write all of the function with heading, with the body right here, and then before main you write the heading or the prototype of the heading again. So it knows that you have declared this function, and it's going to come here, and then it's going to transfer the control over here. But if you don't declare, it's not going to know that what function. For example, you have declared a function larger here, and you've given it parameters. It's not going to know where to go after this calling this function, where to transfer the control to. But if you have given the prototype before the function main. Now it knows where to go. It will go right here and it will solve, and it will return a value, and that's going to be outputted. But also if you write the whole code on before the function main, if you write your whole function before the main function, you're not going to have to write the prototype. You just have to make the function, and the function will, and that way the function main will know what what to do when the function is called. Alright guys, thank you very much. I really enjoyed giving this lecture, and I hope it helps you as well. I'll see you guys next time.